are a independent samples t-test and the one-way ANOVAs. So the t-test, as we kind of talked about, is comparing two groups with a continuous outcome. So, an outcome that's a number like strongly agree to strongly disagree, not like a yes, no, or a category. And so that's what you guys have about like how confident did people feel, how well could they evaluate their biases. Your outcomes are all continuous. But I will say there is a big caveat here that normally when people think about pre and post, they are thinking about like following the same people over time. But for you guys, you had a pre-group that was not paired with a post group. So you guys know that, but if anybody else is watching this video, when you're normally thinking pre-post, that would not be two independent groups. It's only an independent sample t-test if you didn't follow the same person pre and post. So here we just have this random group of people pre, and then this random other group, some of them took the post, but we're not following like Sarah Beth today and Sarah Beth tomorrow. And that's what makes it independent samples. And so, yeah, I think I was just reiterating it here. And so the difference, that's where I put that. The difference is that a one-way ANOVA, exactly the same, but it looks at more than two categories. So pretty much the same statistic in some ways, it just adds on categories. And that's what makes it kind of harder to work with. But so here's the t-test. This is how your printout will be. I did have those colors. And so I'm circling the things you'll want to note. And then I type out exactly how you guys type it up. And so this will apply to your research forum abstract. I don't think you're going to have the text count to type up like every single result, but when you guys are writing your abstract, this is all the information you would need to write up any result that you have. And I can help you guys figure out which ones are the most important. But just to start, you can just see the N is the number of people in each group. Now, in you guys's stats, I put the post group before the pre, and that is related to understanding the results of the effect sizes. So just like be really careful when you're doing this, that there is a good reason that I put it this way, I swear, but it make it a little bit annoying writing it up, so be careful. And so you've got the mean next to the N, and then you've got the standard deviation, which, as we kind of talked about, is kind of like how variable or random the results are. So I drew this really high quality picture to show you guys what I mean. And I think the picture speaks 1,000 words on that. And so to just, you're pretty much always going to want to give descriptives, not really on your abstract. I mean, you have like a 400-word abstract, but if you're writing a paper for a whole entire journal article, you'd give all of these. Your research forum, we can probably make a table with all of these. And so I've just written down here what that would look like. And you're just showing, okay, pre, and here's where I got each of the numbers. And so you would type it out just like that. Does that make sense? I know that was really basic. I just I always want to make it too obvious instead of not obvious enough. So I hope that helps. And then, so when you're on your output, first you'll see before each t-test what we just looked at, the group statistics. And then you see the t-test, and I'm going to walk you through how you get each number and how you report it. So the Levine's test for equality of means, until you're at like for the type of projects you guys did, and for most types of projects, this is something you could completely ignore. It has to do with if like one group was way more random than the other group. And even then, not everybody takes that into the account. It shifts the statistics just a little bit if that's true. Some people use it, some people don't. Psychologists, we really don't. So for you guys, unless you get into a situation where somebody is really wanting you to use that, I just pretend like it doesn't exist. And then what it says on this test is the equal variance is assumed top row. It's testing, this test is seeing, is there equal variance between the two groups, the pre and the post? And so where it says not assumed, that would be on the bottom row. You're saying, okay, they're different, so I'm going to do this modifications to this statistic. But since we're just going to kind of like ignore the Levine's test, we're ignoring the whole bottom row. So we don't even care about any of that. If that makes sense. It's really for if you have one group that is completely not random at all and another group that is just like crazy, then you'd probably want to take that into account. And then next you have the t-value. So that's just a number that goes with the t-test. You have the degrees of freedom value. It's related to the sample size. So usually it's very close to the full sample size. It can just kind of depend a little bit depending on test, but it should be about the same. And then you have the significance. So here's where, this is what I think happened previously, is if you look at the significance for the Levine's test, you can get yourself confused really quickly, especially if you're really tired or something like that. Never look at that significance unless you're going to use it. It's just not even relevant. I wish I could just not even print it out unless I had a need to. Some people feel differently, but only look at the sig two-tailed. And that will be on the top row. So that's like all you care about. That's the p-value. If it's less than 0.05, it is going to be significant. And so these are just all the numbers that we just talked about, and you have to write them up in this kind of like non-intuitive way. Is italicized t, parenthesis, the number for the degrees of freedom, equal sign, the number for the t, and then an italics p, and then the p-value. And so that's the reason that I mainly made this video, is to kind of like walk you through that order, because if somebody walked you through it, it seems so obvious and it seems like, wow, that was a lot for what this is. But if you walk yourself through it, I just see too many errors. I can't take it anymore. That's why I have to make this video. So here we see, okay, the T is the 2.31, the DF is the 191, and then you have the P. And so this is my fancy drawing of putting this all into one. So these are where the numbers came from, and this is how you'll put them. And then I did just want to say the T is always italicized in lowercase, same with the P. Don't italicize the numbers. I'm not very OCD, but this is probably the only thing in the world that gets me. So please follow these instructions. Your reviewers will like you better for it. I wouldn't let you turn it in if you did it, but still, it's important. And so when you put it together, like for this question, it was about confidence addressing concern related to repro healthcare in their field. And so you just say like the sentence just like that, and then you just pop that in that exact formatting. And then if it's not significant, you could say that there is no difference, but I think it's better to just say there wasn't a significant difference, because what if you had like 1 million people and you saw that, it could be related to how many people did it. And so you would usually just say not significant rather than no difference. That's kind of a judgment call. And sometimes you do want to go back and report the mean and standard deviation. That's my preference a lot. And so if you do that, there's multiple ways you can do it. And my preference is just to say the mean equals and what the number is, and then the standard deviation equals and the number. And then I'm putting in my little comments about what you should italicize and capitalize. And so here, you would see it put all together fully. I've got the sentence, the t-test, and then the means and the standard deviations. That would be the results that you want to lead with or highlight in your abstract. You would write a sentence just like this. This exact sentence might be in your abstract. Because people do want to know how big the difference is. You know, if you tell them earlier in the abstract, like, these questions were a scale of 1 to 5, if that's right, and then they can see, okay, it changed from 3 to 3.5. That's how much. I do prefer for people to go out 2 digits for everything but the p-value, and then go out 3 digits. I just know sometimes it's kind of weird, like, what should I do? So that's a good recommendation. And so, yeah, for the ANOVA, 3 or more groups, 1 outcome. And so in this first thing on your project, we talked about the pre-group versus the post-group. These analyses, they don't matter if they're pre or post, it's all combined, because this was looking at education group, where you 10% through your program, 25% through your program, 50%, or 75%. And so in your results, I just ran a table like that too, because probably on your poster, people want to know like what that breakdown was like. And one reason I went with the breakdown that I did, combining 75, 90, and 100, is because that made all the groups about the equal size. And so, and there weren't really that many in 90 or 100. So I just thought it made more sense. And then you get the ANOVA result. This also has a bunch of random stuff that's not important. The F is like the F of the ANOVA is like the T of the t-test. Then in ANOVA, it's like weird. You have 2 different degrees of freedom. One of them is really small, and one of them is almost as big as your sample size. And you do list both of them with like a comma in between them. I could tell you more about what it means, but I don't want to torture you guys right now. That is so boring. Then you have the p-value. And so I crossed out all the stuff that's to ignore. It's just not, I wish I could just print out. I wish I could program it, just literally tell me what I want to know. And here's the same thing, the same formula, just like with the T. And so here you can see you've got the F, and then here's where the 2 degrees of freedom came from. I put the comma between them. And so it's basically the same. I was noting, do make sure you list the small number from the top row first, and then the bottom degree of freedom second. And so it looks like this, but on this output, it did say the p equals 0, but never put that the p equals 0. Always put this, if it says 0, say it equals less than 0.001. Because if we say it's 0, it's like saying, it's like guaranteeing something in a way that we cannot. So just always say less than 0.001. And so if it's not significant, you're done. There's no difference between these education levels. If it is significant, this is a lot that I drew on here, but you want to know what the differences are. Like, is the blue different than the orange? Is the blue different than the green? So blue different than the red? Is the red different than the green? You know what I'm saying? So you want to look at, it's like, where is the difference? That's when the ANOVA starts to get kind of annoying. I drew this like example that was like the 10% and 25% were looking the same, and then the later ones were looking the same. And so like one question I would want to know when I'm looking at this is like, is it a layout like this? Is it probably like when they start their clinical years, they know a lot more? Like, where is this difference? Is it going up a little bit every year? And so again, like if the ANOVA is significant, you just know there's a difference somewhere, but the post hoc test tells you where it is. So don't look at it if it's not significant, because that wouldn't even make sense. Like, you already know there's not a difference. So you're just going to go on a journey that's a waste of time. So You're welcome. Because they're really long. Like that's why I don't really like doing them. Is the output tables are really long. You see it below your ANOVA, and I thought I pasted like the bottom half of this table, but we have the top half twice. Don't worry, on your real output, you have the whole thing. And so what I'm circling on the top row is a saying, it's like a table, like, okay, for the 10% category, how does it, is it significantly different than 25, than 50, than 75? And then you go over and you see, and so what you do see here is that 10% wasn't significantly different from 25 or 50, but it was significantly different than 75. And so you would go through and do that for each category to see where there were any differences. Like you can see below, it's the same thing for 25 versus 75 is different. So, oh yeah, I crossed this stuff out, ignore this stuff. Then I feel like I was getting really into this. But yeah, you can tell that those were the insignificant, the non-significant and the significant one. And so, yeah, here I'm just re-explaining this one so you have it for your reference. And so this is cool. This is the real graph from this question. And so it's exactly like how it sounds like when you're looking at that 10%, not really that different from the other two, but all of a sudden at 75%, it jumped way up. And so for all of you guys's ANOVAs, you have a graph like this, and you can like, a picture is really worth 1,000 words on them, except I was getting tricked when I was looking at your graphs. SPSS will make the range of the graph go with how different it was. So like if they went up from like 3 to 3.25, the whole range of the graph might be like 3 to 3.5. If they went up from like 2 to 5, suddenly the range is bigger. So you have to look at the range on it. Like if it's not significant, look at the range. Probably the numbers are really, really close together. And then it's just too zoomed in, if that makes sense. But when you're looking at your differences, double check it with the graph, and that's what really shows you what's going on. And so you would write it up pretty much the same. You have the sentence, you have the formula, and then you could say the mean and standard deviation of the groups that were different. Like in this case, you could say like, you know, the 75% group, this mean and this standard deviation were different than potentially like all three of these other ones, and those were their scores. But then you shouldn't like write out like every single thing, like 10 versus 25. Like don't write down something that would like really put you to sleep. Just highlight the necessary ones, but you don't have to get into the weaves on every single possible combination. So that is all I have. So I'm going to stop the share, stop the